The next file I will ask you to work with is the one called dividing curvature. And the moment you open it in Grasshopper, you will see that the curve container and some of the point as lists components and the point list display component are colored orange, which means that there is a problem with them. You will see also a small pop-up above them. So if I point towards that, it says this object contains one warning: a referenced curve could not be found in the Rhino file, right? So this component essentially tells us there is something wrong with my input. I want you to resolve it. Same goes here, right? So whenever we have a problem here in one of the initial components in Grasshopper, you can expect that this will surface also as a problem in some of the components downstream. For this particular case, the solution is very simple, right? I've prepared a file for you to open. So if you go to File, Open on Rhino, and you find the Divide Curvature Rhino file, this will open directly a file in Rhino that contains a curve. Obviously, you don't have to use that particular one. What you could also do is, sorry, I have ortho enabled. I'll just disable that. And I'll try to create another elaborate curve. And this is now the beauty of parametric definitions, in the sense that whatever I have calculated or computed for this curve, I can do the same by changing this container and its connection with this particular curve. And I do that by right-clicking on this and set one curve. And you see how my definition essentially jumps. Let us take a look at what this definition is doing, and then we'll return into playing a little bit more with dividing curvature and merging data. So this is essentially a container. You can find containers on the parameter and main menu folder. And these essentially are containers that connect with the Rhino main geometry. There are various types that I invite you to take a look and play with. The one I'm using in this particular definition is a curve. You see I click on here and immediately it turns to orange because it is not yet connected. So click and set one curve, and I connect it directly with that one. The point I have here, the component I have here is called divide curve. And essentially what it is doing is it is taking a curve as input, and it is count. It receives also a number, which I will do is as, let's go with 17, which is a nice prime number. And then it outputs 17 points, and also the tangents, so essentially the lines that are tangent to those points, and parameter values are division points. To be able to visualize these points, what we do is we use a points as list. Point list. And also we can use a slider for the size. And essentially what this does is it numbers the points so that you know, for example, that this one is point number 5. And this is very handy because when you are looking at a point list as such, point number 5 is number 4 on the list, and it doesn't help you get confused. Sorry, point number 5 is point number 5 here, right? Because it starts with 0. And points of display are located. Let me try and find these. As such, and what this is doing is it is creating a vector from each point to the next. This is a little bit more visual, ready to see here. Try to create your own kind of list. I will also try merging data streams at the moment, right? So I have two curvatures. If I merge, then I take the result and I input it here, I essentially get and cancel that part. I essentially get both curves analyzed with the same algorithm in 9 points, right? So every time I change this to 14, the numbers increase in both curves. So try playing with your own divisions and try as an exercise to connect, say, point number 10 with on one curve with a point number 10 on the other.